I wanted to show you a conversion I've done of my G0704 Mill to CNC, and I've also converted the motor to a DC direct drive with a belt drive up here. And so I'm using a Planet CNC. You can see the screen of it back here, controller, and I've got the Planet CNC board. And I've got a control box down here, which I'll show you afterwards. The Planet CNC board has a jog keypad here, which I've got wired up here. This is the control keypad for the motor. And I'll give sources for all this stuff in the description. And then I've got conversion for X, Y, Z axis motors. And the conversion I used has, you can leave the wheels on, but honestly, you never use that. Everybody says you never use it, and you actually never do use it. So I've got a speed dial up here, so when I move these, I can slow it down then, and you can adjust the speed on the fly. So as you're So that's 5, 6, 7, take it up to 12, and full speed is 40. So that's really convenient because you end up using these jog wheels all the time. So to be able to jog it and then just roll, the way I did this, I've got a nice knob on that's very easy to maneuver, and so I just twist it with my fingers as I'm using it, slow it right down. So I've got the X, Y, and then I have Z motion here. And I have the Z motion set, so when I let it go, it stops. So I can go right down close, boom, and it just absolutely stops at that point. Now the motor speed control has a start button, stop. You can change the speed here, and it's got a forward, reverse, and a tapping function, which just sets it to speed of 500 in here. Which so I've got a 4/3 or 3/4 speed, 3 to 4 ratio on the belt drive up here. So the maximum motor speed is 6,000, which works out to 4,500 RPM. So if I start up the motor, so that's 2,000 RPM at the spindle, and there's no gears in there at all, so it's just straight motor across to the belt, and that's using the Haas conversion. And it's nice and quiet. And when I put it right up to 6,000 RPM on the motor, it's very smooth. I do notice the bearings in here get warm. I did a bearing conversion as well, so I upgraded to much better quality bearings. There's 4,000 here, 3,000 RPM at the spindle. When you stop it, stops right away. Start it. And I have an e-stop in here to stop it right away. And so there's two e-stops. So what I've done is I've got the e-stop purely for the motor here, which is just an easy way to stop the motor. And then this e-stop stops the motor and stops the any CNC work that's going on. So this is sort of like stop everything. This is just stop the motor. So it's probably dangerous to have two of them, but at least this one here will stop everything. The tapping function, well, actually I'll show you when you get it going, Fast forward, if I just click reverse. It's going in reverse now, forward. And it remembers that. So it'll go back to that speed when it's done. When I turn the power off and everything, when you turn it back on, it remembers the speed, remembers the direction. The tapping function, I don't know if I'd ever use it. So there it's at 4,000 or 3,000 RPM here. Hit tap. Just slows down to 500 here, which is just a little under 400, 480 RPM probably. So it's probably good for tapping, as I say. When you click it, again, it goes back to its normal speed. And so yeah, everything's pretty smooth. I still want to adjust things in here. I've got limit switches on X and Y and Z, and I put the limit switches in here. I just built a little little bracket that holds the switch, and it really just slams into the switch. But it stops so quickly that it stops before it does any damage to the switch. So it doesn't work too bad.
This image shows one of the two Y limit switches. They're Honeywell switches, easy to adjust. And you can see the DRO that I had previously used before I converted them into CNC. This image shows a bracket, sort of C-shaped bracket that clips over the ways and for the X limit switches. And then there's a little bracket at the end that actually holds a limit switch. It smashes in, but it stops so quickly that it works fine. Here's the Y-axis limit switch. Here's the Z-axis limit switch, and you can see a DRO scale there on the left. It's not used anymore. There's a bracket that holds the control boxes for the motor speed control and the jog controls. And you can see the Z-axis switch there, and up on the left you can see there's a sort of a little metal cylinder that the Z-axis switch hits. The Y-axis motor on the rear is incredibly convenient. It gets it out of the way of the front of the machine. But you have to drill a 1-inch hole through the column. So I started at ½ inch, or quarter inch, and worked my way all the way up to 1 inch, 1/16 inch at a time. This is that Z-axis motor on top of the machine, and the X-axis motor on the left of the machine. And there's the two motor control boxes. Some close-ups of them. There's the spindle motor control box and the jog motor control. I tried to do those on a laser, but I had to CNC. Here's the belt drive, and you can see a little metal panel at the front that protects my fingers from touching it. I used Haas's plans for this. It worked great.